Hi everyone, I'm Utku. Today I'm going to be presenting floating solar panels in Keban Dam. We will install some solar panels on the Keban Dam water surface, and we will produce some energy from solar panels in addition to hydroelectric energy. Both solar energy and hydroelectric energy are important for Turkey. In terms of solar energy, Turkey has a high solar reception period, and regions where the sun's rays are intense, especially the Mediterranean, Aegean, and southeastern Anatolia regions, are leading in terms of solar energy potential. Solar energy attracts attention with its advantages such as being a sustainable energy source, reducing energy imports, and having low environmental impacts. Turkey is also a very rich country in terms of hydroelectric energy potential. Turkey's geographical location and extensive water resources provide a suitable environment for hydroelectric power generation. Hydroelectric energy is considered an environmentally friendly energy source and provides additional benefits such as water storage and management.
Hello, I am Cumali. I explain aim of the project. In this research, the energy that the Keban Dam, located in Elazığ, can produce solar panel in addition to the energy currently produced by the hydroelectric power plant, and its details are mentioned. Electric energy will be obtained from the sun. Those floating solar panels that are intended to be installed on the surface of the dam lake, and it is aimed to provide and increase the hydroelectric energy production as a result of the reducing the evaporation of dam water by covering the water surface. The main purpose of the dam is to provide power generation and irrigation water. Keban Dam consists of the 5 hydroelectric power plants with a total installed capacity of 1,330 megawatt. Dam Lake is one of the largest lakes in Turkey with a water volume of 40.4 billion cubic meters. This water is used for electricity generation as well as for the irrigation purposes. The basic formulas for the hydroelectric power generation are as follows. Potential energy is equal to mass of the water times gravitational acceleration times height differences. Kinetic energy is equal to 1/2 times mass of water times velocity of water square. The power used for the production of electrical energy is calculated by the following formula. Power is equal to efficiency factor times water density times water flow rate times gravitational acceleration times height differences. In the case of the Keban Dam, power generation can be calculated by determining the values of parameters such as water flow, height differences, and efficiency factor. Hydroelectric energy calculation for Keban Dam. Q is equal to the average annual flow rate of the Fırat River is 635 meter cube per second. H is equal to the height of the Keban Dam from the stream bed is 210 meters. P is equal to 1.177 gigawatt. Water loss in dams. Water loss in dams is usually caused by two main factors, evaporation and leakage. I will explain two of them. First of all, evaporation. The water stored in dam lake evaporates under the influence of sunlight and temperature. The evaporation rate varies depending on factors such as water surface area, temperature, humidity, wind speed, and vegetation. Leakage. Leaks may occur during the construction of dam or in the ground layers located under the dam body. These leaks are related to the structure of the dam and permeability of the ground. Various methods are used to reduce water loss in dam projects, causing that reduce evaporation, vegetation. Various methods are used to reduce water loss in dam projects, causing that reduce evaporation, vegetation management, floating obstacle, permeability blocking barriers, storage underwater.
Hi everyone, I am Ahmet Karakuş. I will give some information about Keban Dam data. Water storage capacity. The total water storage capacity of the Keban Dam is approximately 31 billion cubic meters. Evaporation. The average annual evaporation amount is about 1.5 billion cubic meters. Hydroelectric power generation. The total installed capacity is about 1,330 megawatts. Annual energy production is about 5 billion kilowatts hours. The purpose of the project. The main objective of this project is to minimize the water evaporation at the Keban Dam. In this direction, the floating obstacle method was used. In addition, we aim to place photovoltaic panels on the dam surface in order to minimize evaporation as well as to ensure renewable energy production. Floating solar panels. The principle of operation of solar panels. Solar panels convert solar energy into electrical energy by using the principle of photovoltaic effect. These panels allow semiconductor materials in contact with sunlight to absorb solar photons and release electrons. The released electrons act on the circuit, creating an electric current. Solar panel technologies. Solar panels used in dams are usually based on crystalline silicon or thin film technologies. Crystalline silicon panels. Monocrystalline and polycrystalline silicon panels are among the most widely used solar panel technologies. Crystalline silicon panels offer high efficiency and long service life. Thin film panels. Thin film panels such as amorphous silicon, cadmium telluride, or copper indium gallium diselenide have the advantage of lower cost on flexibility. Installation of panels. In dams, solar panels are usually placed on the upper surface of the dam body or around it. These panels are usually oriented towards the south in order to make maximum use of sunlight. The optimal positioning of the panels increased their efficiency. Electricity generation and integration. Solar panels used in dams can be integrated with hydroelectric power generation. Electricity generation increases the total amount of energy obtained from both solar and hydroelectric energy sources. Performance and efficiency. The performance of solar panels depends on many factors, such as the duration of exposure to sunlight, panel efficiency, cleaning condition, panel angle, and environmental factors.
To continue with energy production from floating solar panels, the amount of energy obtained from the solar panels depends on many factors. These are solar panel efficiency, total area of the panels, the duration of the exposure of solar panels to sunlight and climatic conditions, and the location of the dam. Remember that solar panels provide energy production from sunlight, and therefore energy production may be lower at night or on cloudy days when the sun does not constantly give light. To calculate the solar energy power, the following formula is used. Solar energy power is equal to solar panel area times sunlight flux times solar panel efficiency. To do that, we've gathered some information from PVGIAs, some detailed way of the month values. It was obtained that the Keban Dam has a lake area of 675 kilometers square. It was decided to install these solar panels to Keban Dam's surface, one per 1,000 part of the lake area. And Elazığ's sunlight flux data was taken from PVGIS, and the efficiency value was taken as 20%. In this case, the solar energy power will be calculated. The monthly and yearly total energy from the photovoltaic power plant is shown in the table at the right side, in the middle of the slide. And the monthly value of G was used to calculate the P power values. The total in this project, the solar panel system can generate electricity with a power of 264.36 megawatts. To conclude, this project aims to obtain renewable energy from the sun in addition to the energy obtained with the HPP available at the Keban Dam. In this direction, it was decided to cover a certain part of the surface of the dam lake with photovoltaic panels. Thanks to this, solar panels were prevented from occupying agricultural land or other useful land. In addition, the installed floating solar panels prevented water evaporation because they covered the water surface. Thus, it has contributed to hydroelectric energy. As calculated in this project, the current energy production of the Keban Dam is 1,177 megawatts. If 1 per 1,000 of the lake surface is covered with solar panels, an energy of 264.36 megawatts can be obtained. These solar panels installed on an area of 1 per 1,000 in the lake provided an energy increase of 22% compared to hydroelectric energy. However, since evaporation has decreased, it has contributed to hydroelectric energy at a certain rate. Thank you for listening.